Hello there, and welcome to episode 69. Episode 69 of GLSL. Doug and I, welcome to the stream. Good to see you. Yes, episode 69. I can't believe we got so far. So, and it's another shader stream today. So we're going to be kind of returning to our terrain shader, but we're going to start off looking back at the water shader that we did last time. I think that's Mårten's plan. So let's not hang around too much. Let's go straight over to our pair programming stream and let's introduce Mårten.
Yeah, hello there.
Hi, Mårten.
Back on the stream, so to say.
Yeah, it's getting to be a regular spot now, isn't it? It's really good.
Yeah.
So
we have Dragoneye. I think I've seen him before.
Yeah, Dragoneye's there. He's our loyal shader follower.
Yeah. And hopefully some more people can come in and listen to this. So, yeah. So have you been thinking about this the following week?
Yeah, so we kind of talked about getting some clouds and things and getting this water effect into our kind of mountain shader, which has actually improved since the last stream. You'll remember, viewers, that there was we were kind of a bit worried about the shadows on the mountains. They looked a bit odd, but actually Mårten fixed those off stream, and so it looks really good now. But we won't show that on stream just yet. We'll wait till we're kind of ready to show that. But it's all the stream. The shader's also up on Shader Toy now, so I'll show you that a bit later on as well. So it's available to go and view, and actually the code's there, so you can actually tweak the code yourself and change things and see what happens.
Yeah, we also made it compatible with Microsoft Edge.
Yes, it was crashing on Edge.
Yeah, the reason was that there was a WebGL1 that came out, and then there was a proposal for WebGL2, and some of the browsers moved over to that. But Edge, I guess since Microsoft are looking to go to the Chromium.
Yeah, Chromium Edge worked okay. That was okay, yeah.
I guess they're not really working so hard on keeping it up to date.
I'm a bit loud. Oh, yes, you're right, I am. So let me just sort out this. I'm a bit loud. So that was because we had a bit of a microphone issue. So let's just sort that out. Now, is that? Oh, it's still a bit loud. Bring that down a bit further. Now, how's that, Dragoneye? Is that better? The reason why I don't know, when I was just warming the stream up, and the microphone volume level was very low, so I boosted it. But of course, typically, when we come on stream, it's absolutely fine. So there's a bit. I'll just down it a bit more. We're in the yellow, so that should be okay. So thanks for Dragoneye for. I didn't mean to ask about the volume levels. Okay, so Mårten, we've got this kind of rather wonderful kind of seascape here with the sun and the waves.
Yeah. So what we're looking on here is, for people that maybe wasn't here last time, we're looking at a very simple skybox, which just shows a sort of a sun as a sort of a circle with some aura, and then we have a water plane, which actually is a flat plane, and then we compute kind of the sea height by aggregating multiple sine waves together of falling amplitude and increasing frequency.
Which is our kind of model, isn't it? So we do that a lot.
Sorry?
We do that kind of a lot with the white,
yes,
combining sine waves.
We will continue doing that to create clouds, because Wonderful. It seems that this is just the way how you roll with creating these kind of things. So, and this actually looks pretty good, I think.
Oh, it's great, yeah.
Considering the simplicity.
Yeah, we're looking at, 120 lines of code there.
Yes. And the nice thing about this being a plane that you hit with a single ray is that this is quite efficient. So this probably performs quite well on even a quite bad telephone or my laptop, because it is not. It's a few gigaflops per second, but for a graphics card that is nothing.
Yeah.
Because they do teraflops. So a few gigaflops, that's okay. So I guess what we can do what we can try to do is to try to sort of create a cloud look and then integrate that cloud look into this simple shader, and then when we're kind of happy with that, we can try to move it to the terrain shader.
That sounds like a plan.
Yeah. So in order to do so, I guess we now start a new project.
Okay. So I'm just going to find out what this one's called. This is 7, so we're going to do 8.
That's the hardest problem. Naming.
Yeah, naming things, yeah.
Not for me though. I name everything A, B, C.
Yes,
you know.
You're very simple.
Yeah. And the good thing is when the meaning change, you don't have to change the name. It's just you just make a mental note. Yes, now A is something else.
I used to I did flirt with a programming language. It was actually kind of a database programming language called Mumps.
Oh yeah, that one.
And I think you could only have single letter variables, and you could only have A to Z. That was it. So you had 26 variable names to play with in the program. That was a lot of fun.
I read about Mumps. I never really done anything with it, but isn't that a kind of a disease as well?
It is. Mumps is a childhood disease, yes.
Yeah, so I mean, the name is, I think it's kind of weird, but I think it has some pretty good integration with the database, a little bit like Fox Pro or something like that.
Yeah, that's right.
I don't remember.
But I didn't flirt with it for very long, so.
No. So let's create a kind of a simple. In order to make this look better, we can create a kind of simple kind of sky look to it, like a blue shaded sky.
Yeah.
So the first thing we do here is we have the position UE, perhaps. And what we do now is we want to sort of correct the x-axis, so the ratio is correct, right? And that is a standard procedure these days, how to do it.
I'm just going to change
if you remember it.
I'm just going to change the resolution here.
Yeah, that's a good idea.
So I can never remember how to do these things. I have to admit I go and pinch code from the previous versions though, but I think it's something
this particular one I've done so much, so I think I can do it from head.
You go ahead and type it in then.
Yeah, okay, I can do it. Well, apart from me being unable to sort of,
I'll help.
Produce. I need a multiplication sign.
There you go.
Is the equal over here? Yeah, here's the equal.
Working okay. This is resolution. So this is where we're just adjusting the for the resolution of our screen.
Where is the division?
There you go.
No, I typed wrong here.
It's okay, there we go. Oops.
Yeah, that's dangerous.
Yeah.
Can do it. No?
And then that file new U there.
You spelled it for me. Oh yeah, I have a new extra there.
Have you got it?
You remove it.
There you go.
So now the rate is fixed. This is just something you learn to type, and after a while it's like becomes signature.
Yeah.
So I think we can create kind of a blue kind of sky, and I have some values which I experimented a little bit with before, which I think can be useful. So I'm gonna paste them in the.
So we're using code share IO here just to share code.
See if that was successful.
Yeah, that's fine. I'll copy them across. And what we're using here is Kodelife, the Kodelife IDE. So if you want to kind of code along with us even, then just go and grab a copy of Kodelife. It's free and it's from hexler.net. And it's what we're using.
And I can type a little bit here, see if I can handle it, of course. Vec3 call. Yes, equals.
Doing well.
These are the normal characters. And then we say here, col, like so. Now what should color be? Well, what we do now is then we mix sky col. No, why? Yeah, I'm gonna save some.
Yes, I thought it'd be too long for you.
And also, we seem to never remember if it's with a U or without a U, right?
Yeah. It's the UK spelling or the US spelling, yeah.
Yeah, so it's just better to sort of remove that ambiguity. So mix is a very useful function, often used. No, apparently not working.
No.
Like so.
There's a nice shade of blue.
So by changing between 0 and 1.
Yeah.
And so it's just a linear interpolation.
Yeah.
It's very, very common. And now we can say, okay, uv.y.
And we get a nice graduation. Yeah, lovely.
Yes. But this is then between -1 and is this the way you want it, or it should be the other way? I mean, that's good. And now it's still. So what this UEY, because the thing we did up here is between -1 and 1.
Yeah.
So this now go between 0 and 2, and we wanted to go between 0 and 1.
Yeah.
So we're just gonna multiply by the multiplication sign.
There we go.
My nemesis. Yeah, I done my part.
Lovely.
Yeah, but so it's good to have a little bit sort of kind of a natural looking sky to it, because then when we try to add clouds to this thing, it's gonna make it simpler for us to do so. So how do we do clouds? That's a good question. Now, so what we can do is we use this noise generator again, which was very useful last time.
Yes.
So we're going to use it again, and the way you do it here is we use the shader states, and you can then change. You can add a new texture. Sorry, I'm writing a little bit here.
Okay.
There we go. So what you do now is you can remove the texture 1, 2, and 3, and 4. We're not going to use them. But you can add pictures. So for instance, if you like the idea of doing like a slideshow of different pictures, you can have each picture as a texture or a video.
Oh, okay,
so
right.
If your intro you had before, you could add all these kind of things to have as texture with video in them. And then you can sort of, fade between them. Instead of using an editor program, you can use a shader. Write a shader folder of that and do it real time. And things that are real time is obviously better than things that are not in real time, in my head.
Yes, absolutely.
So then we add a new parameters. It's considered parameter. So you have a plus sign there next to parameters too.
Parameters.
It's kind of middle screen.
In the middle. Parameters, yeah, there we go.
And then you take the plus sign there.
Yeah.
And then you go built in, I think, and then it's called noise.
Noise, yeah.
And a good resolution can be 512 times 512.
Resolution 512 by 512, okay. So these are similar to what we did last time, I think, with the mountains. Okay.
And then we're going to change the type. We can use, for instance, Perlin noise.
Yeah.
It's often considered quite good for these kind of things.
Okay, that's what we use. Once again, we use Perlin noise to generate a mountain range in Kodelife, and I think I used another noise texture in Shader Toy to create it, but it was pretty much the same kind of thing.
Gray noise.
Yeah.
Which is like a joke, I suspect, on what's called white noise.
Yeah.
But I don't know the definition.
There's also, I mean, in audio programming, there's pink noise, which is more towards the so-called red end of the sound spectrum. So.
Okay. Wow. It turns out noise is complicated.
Yeah, I think it is.
And have different interesting properties. So I'll go with. We can start with pearly noise. What's nice here is we can always kind of we can always tinker and change with it. Later on.
Yeah.
So the end result is we're going to do the same thing we did before. In that we're going to take noise and then add noise again on top of the noise, but reduce the amplitude and increase the frequency, and then so it's going to be very similar to how we do mountain ranges, but if you apply different coloring scheme and different kind of approaches, we can make it look more cloudy.
Right.
So let's try to do that. So I would make a function that you maybe can call clouds or cloud or something like that. Cloud color, or cloud color.
Cloud call.
I would, So that's good. Yes. And that takes us position two-dimensional coordinate, vec p to p.
Okay.
And the reason for that is we want to have a color. It's going to be a flat kind of. I mean, clouds are obviously not flat, but when you look, if you lie on your back and look up into the sky, right before you, you can imagine kind of being flat.
Yeah, absolutely.
So okay, so let's create something simple now. So let's just sample this color, and then you say vec3 col. Yes, let's make that vec3 col equals 0. Yes, you have to make vec3 0.
I should be used to this by now, but
and then
you out the window when you're on a stream, I'll tell you.
And then you return call.
Okay.
Actually, maybe we should make. Maybe we should return a vec 4. We want to return clouds or have transparency, right? So maybe we want to return.
You've got the alpha channel, haven't they? So yeah.
Yeah, but alpha channel, yes.
Okay.
So, and what? Oh, you have to change vec3 0.
Just to 1, is it?
You can do that, but it's also the wrong type.
Oh, of course it is. Yes. Yeah. There we go.
But the alpha should be the last one should be 1.
Yeah.
So that's correct.
Okay, don't.
Good. So what we can do now is we can call this function. If you go down here, and you call this function at line 41 or something like that. And you pass in UV as the argument there.
Yeah.
And then we update col. So col will now be col equals mix between col and the cloud .xyz. So here we select
that's the color part of it, yeah.
Yeah. And then the mix factor is the cloud.w, I think it is. I forget.
Yeah, I think it's W.
The last
It's the alpha transparency part of it.
Let's see if someone has some questions here. So that's black. That's kind of expected. So if you go up now and you change the alpha of the cloud call here to maybe 0, it should be blue.
Yeah, so it's completely transparent.
And if it's 0.5, it should be
grey cover.
Yeah. Yeah. So that now we can implement an alpha channel here. So when we are computing our cloud, then later on, and that will have different alphas, then that will be faded into the background with different degrees, which is what we want.
Yes.
So how do you do that? We can change back to 1 here. So what we can do is we can just sample. Well, we can make. I'm future-proofing here a bit. We're not going to make it, but I'm future-proofing because I know
where we're going
about this during the week. So let's make a function that's called noise, and this function returns a float, which is the noise value, and this takes a position p. And returns, and what you do here is now what you return is that you sample the texture. So you take texture like that, yes. Parenthesis, the name of the texture, which is texture 0. Oh yeah, it says noise, so you should change it, but texture 0 I think is the name.
Okay.
And the value p.
Okay.
And you have to select the x-axis.
X, yeah.
No.
Just the x of the
texture returns 4.
Okay, yeah. That's fine. Yeah.
Yeah. And now you change the name of the texture here, so you have it's the right name.
Texture 0. Let me spell it correctly.
Yeah. So
does help.
What you do now is you sample the noise. So I don't know, you say float n or whatever. I don't know what's it going to be, but say float something, an accumulator or a sum or whatever.
Upon the line 34,
so
yeah.
You declare a sum.
In cloud call.
Yes. Before, yeah, that's probably true. Yeah, that's good. And then it starts by 0.
Yeah, I've got an n. Look, there's I'm falling into your way of thinking.
Yes, and then we just sample the noise value. So take n plus equal noise p.
Okay.
And now you change the call so that it's white instead. So you go 1 1 1 1 1. And you change the said this thing to be n.
Okay, there you go.
So it's not perfect at all.
But it is varying, isn't it? They got varying transparencies there. You can see this
what we can do now in order to sort of, cloud is not this kind of. So what we can do is we can center this thing around the 0. So what we can do is we take the position p here.
Yep.
And take it minus 0.5.
Okay.
I think that's at least true. No, okay, go plus 0.5 instead. Okay, obviously.
There we go, yeah, so it's centered. So you got the noises in the center.
Yes. So we want to sort of zoom in here. This is not the correct sort of, way. So you multiply the vector p with a value. So if you take p here,
yep.
p, and multiply that by 2, for example, what do you expect to see?
It's smaller.
It's smaller, yeah. So we want to go the other way around. So we multiply by 0.01, perhaps.
Okay, so we can see, we're right zoomed in there. You can see the individual noise kind of pixels, I suppose we'd call them, but they're not.
So the problem we're seeing here now is that it looks very blocky, right? That's not how clouds look, and that's actually quite simple to fix. what you do is you change the nearest thing here into linear interpolation.
Okay. Both of them.
Yep.
Okay, well look at that. Immediately we've got.
Now it's kind of hazy looking.
Kind of cloudy, isn't it? Yeah.
Yeah. So I think actually a good idea to do here is that the noise should actually return something, because when we sample the noise, we get a value that is between 0 and 1.
Yeah.
And I think we should change that value to between -1 and +1, so that it's centered around the 0.
Okay.
So that the average is 0, you could say. So the way we do it, then you take the noise value, the noise function.
Yep.
Up there. Not in the noise function.
Yeah, I mean, okay, the noise function. Yeah, okay.
And if you take that minus 0.5 outside after x1.
Okay.
So now it's centered. So actually, it starts looking a little bit like clouds on my screen.
It does, yeah.
Yeah, but then now it's between minus 0.5 and 0.5. So we want to sort of double the range between -1 and 1.
Double the whole thing.
Yes.
There we go. Yeah.
You have to put the parentheses around texture because of these precedence rules.
Right. Okay.
Actually,
Yes, that's some wispy clouds on a summer day.
Yeah. Okay. So how do we do this thing now? So the clouds here are kind of very kind of hazy. So we want to increase what should you say, one of the things we want to do, we want to make sure is that this value is not negative. That doesn't make a lot of sense.
Yeah.
So then you go the max function here.
Max on n, yeah.
Yeah. So that (0).
Okay.
So because then we make sure that this thing here is
negative transparency doesn't make any sense, does it?
And then we can do things like
oh right, yeah.
We can sort of make them disappear by sort of moving this thing. I was looking for plus sign. Doesn't matter. So we can sort of adjust that thing a little bit. Yeah. Okay, cool. So what we do now is if you take this noise thing here and you add it again to itself.
Yep.
I would also take position here plus equal plus equal. Where's the plus sign?
There you go.
Yeah, maybe 2. Let's see what happens.
Oh, we're getting some cloudy light blobs.
Yeah. Now the problem here is we are just superpositioning here. So
yeah, we need to offset them. Yeah.
Yeah. Now what we do is we reduce the amplitude of the second noise level. So you multiply 1, and then you increase the frequency, but you maybe double it. So you can almost see that the shapes are getting a little bit more interesting.
Mm.
So what we do here is then is we write a loop.
Yeah.
That allows us to sort of experiment with this thing a little bit.
And we're going to do our standard trick of putting an X in here, so we block compilation.
Yeah, and we write a loop around the noise thing here. Not that one. Yeah. That we can leave. The reason we put this loop here for people that haven't followed this is one way to get the ID to crash is that you write an infinite loop in ShaderToy, and then the graphics card tries to execute it, and I suspect then that the graphics card driver crashes, and and then the Kodelife crashes and takes all your changes with it, and then you then you become a little bit sad.
And then we feel sad at that point, yeah.
Yes. So this is what we do here is now by putting the X thing here, we make sure that we write the invalid code, so it doesn't try to sort of, because it's continuously recompiling it, right? Change I to 1, I minus less than 1. And now when we remove X.
So we should be okay. So it should just stay the same.
Yes.
It does.
So now we say, so now we have a loop here. So now we can change this loop here.
So I'm going to say before we do anything else. There we go. Okay.
So let's remove the second noise level there.
Oops.
Not both of them.
Yes, it's my mouse control is not scratch. Okay.
Yes. What we do then is what we do with the mountains is that we introduce this amplitude multiplication factor, amp, perhaps.
Yeah, let's give it.
And then we have a frequency factor. Could be 1 as well.
Yeah.
And then you multiply the noise factor with amp and the frequency, like so. And then after here, what you do is you multiply amplitude by 0.5, for example, just to sort of reduce the noise amplitude, and we increase the frequency by 2 is usually what we do. We can see what happens.
Yeah.
And then increase the loop count from 1 to 2. See if you get the feeling.
Yeah, so that's what we had before.
Yes, and then go 3.
Ooh.
4.
Look at this, it's almost like magic, isn't it? It seems to have reached a limit there, by the look of it. So was it 5?
Yeah, in terms of sort of, precision. But I mean, it's it looks a little bit, with the amount of effort we put in. I think it's
and no new concepts at all there, other than no new concepts at all, in fact. So we've used the textures before for the mountain range, and we've used exactly the same loop and multiplication before to produce the mountains. Yeah, so it's we're not introducing any new concepts, so that's really good.
It's kind of the same algorithm as we did to sort of produce the mountain range. And if you would say to me, if I would see this thing here, and you would say to me, what is this? I would say these are clouds.
In fact, if you look at this little window up here,
yeah,
it's even more kind of cloud-like in that one.
Let us try to sort of let's see 3. Now that doesn't look right.
No.
It looks interesting, but
does it look like a cloud? Yeah, yeah. Oh, that's quite interesting, doesn't it? Yes, that's very much like a cloud.
Yeah.
You get some kind of weird artifacts over here with some.
Yeah, but I think I know what that is from.
Ah, okay.
Yeah, we see we get artifacts here, right?
Yeah.
And I think this is because you see we have clamp here, which means that the texture is limited.
Okay.
So what we want to do is we want to make sure that it is actually repeated. So you repeat it in X and Y.
Yeah.
And now let's see what happens when we.
Oh yes.
So the problem was that we ran to the edge of the texture.
Yeah. Which is why we got the vertical lines. Yeah. Yeah.
So that looks a little bit too detailed. But that looks okay on my screen.
Yeah, it looks really good. I'm going to save that one.
So But clouds aren't exactly, static.
So Dragon Eye is asking if there's a way to figure out what the value should be without experimenting, and my gut reaction would be no.
No.
And that's part of the fun, Dragon Eye, is to fiddle around with the numbers and see what happens.
No, but usually when you do these kind of things, you kind of want to get kind of geometric fall off. So you are probably multiplying, and if you multiply by something, multiply by 2 is probably a pretty good start.
Yeah.
And then what you do is say, okay, 2 was good. Let's try 4. Yeah, that looked weird. 3 then. Okay, that looked cool. I guess it has to do with the noise texture and these kind of things, but I'm sure you could figure it out. But I just find it quicker for me to just change the number and see what happens.
Yeah, definitely. It's part of the fun. That's what the fun of it is to change the numbers and see, because that's what you can go into shader toys. You can go and change the values in somebody else's shader. You're not going to affect their code, but in terms of it running for you, you can take an established shader and play around with the numbers and see what it does, and then just copy the code out.
So it's interesting, but it's not clouds in that sense. So, what is the time here? Not the time here, but what is the time in the shader? Oh, it stopped. Good.
Yeah.
So we should try to add movement to this thing here. And one way to add movement to all of this is plus sign.
There you go. I did that one for you, sorry.
Yeah, it's okay. So that's too fast.
Yeah.
So we multiply that by 0.1 perhaps.
Okay.
If you can do that for me.
There we go.
But the problem is, it's not really a problem, but the problem is that it's static.
Yes, the clouds themselves aren't moving around, are they?
Yeah. So clouds are kind of by nature changing. I honestly think they look kind of nice, though.
Yeah, you could imagine yourself lying on your back, as you say, staring up at the sky on a nice summer's day, and
so
clouds moving ahead.
For the amount of effort we put in, I don't think this is so bad.
Well, we've been going just over 30, well, a little bit longer than 30 minutes, and we've got that as a result. Yeah, it's great.
But what we can do, just to try, that one we're not going to use.
Here we go.
Is that we add a little bit to the position for each iteration.
Okay.
So if you take plus P plus, I can type, but I can't type. I have to find the plus sign. That's the.
Let me do that bit for you. There you go.
So, and where's the multiplication sign?
Got time there, do you?
Yeah, it's kind of what we do. I'm going to comment this thing out. We are sort of, sampling the noise factor at different places.
Let me do
where
that for
is
you.
that?
There we go. Oops.
The division sign.
Yeah, let me get it for you. There you go.
See what happens now when we start this thing.
Yeah, so they are kind of, yes, they are changing quite nicely, actually.
I need to wait on the stream to see that. It's but you can see now that it looks like there are layers and things disappear and reappear.
Yeah.
That's kind of nice.
Yeah, see, you can see this place of the cloud is disappearing, which is evaporating like it would do, and then it's coming back again as it perhaps reaches some colder air. Yeah, it's nice.
I mean, we are not doing any physics simulation whatsoever, but we don't care. As long as it looks like believable.
Yeah, so that's right, Dragon. The noise basically extends in all directions forever now, so it's just repeated.
I actually think this looks. I mean, I don't know how it looks on your screen.
It looks really nice
with this added kind of it moves slightly. I think that adds to it.
It does.
And now it slowly sort of moves. There's another thing we can do here, and you see this thing here reduces the cloud level. And I think that's kind of nice is if we introduce a parameter here that we can say, I don't know, let's call it just off, like so. And now this is parameterized. So if you start sending this, you see it goes like that.
Yeah.
But what's nice about that is let's break. Can you copy and paste? Copy, and we make that into float y factor equal, and we paste it.
There you go.
Thank you. There we go. So y factor, and if you pass in the y factor here,
oh right, good idea.
What happens now? Maybe it's too extreme, but what happens is that as things moves down, the clouds disappear. So let's multiply that by 0.5.
Okay.
Am I right? Or am I wrong? What is 0 do? Yeah, we see that it.
Yes.
When it goes down the screen, and equally if you should put the minus sign here between, then it increases intensity. Not sure that's a good idea, but that we can do it. And this we can use later on because we can then use it to sort of make the intensity of the cloud layer be different at different distances.
Yes.
And that's kind of useful, I think. So shall we? Yeah, but I think we actually.
No, that's really nice. It's amazing how you can do that.
Yeah, it's not like it's it wasn't really like this is mind-blowing math.
No, but it's just it's an application of what we did before, isn't it? We've taken a texture, and before we calculated a height function, and so we built a mountain. Now we're using the noise, the level of the noise, to alter the transparency, the alpha channel of the color white, which is being overlaid against a blue background. We've done some iterations, as we've always done, to get the variation, to make it more a natural looking object, but it's identical concepts. There's nothing new, and yet we get a completely different picture.
Yes, and also the water waves, the same principle, but then we use sine waves instead.
Yeah.
But then we have the same principle that we are overlaying a sine wave with increasing frequency and increasing what's called or decreasing amplitude. But also to make the water slightly more natural, we also rotate the sine waves.
Yeah.
So it comes in at different angles. I think this is not too bad, actually, right?
I think it's a bit harder to see on the Kodelife main screen here because of the way the IDE is kind of framing it, but in the little window up here, it's really nice.
But what you can do is we have a menu item here, right? Which is called toggle full screen. We can try that.
And we can toggle off the
that didn't go as I intended. Well.
We can.
What was I looking for?
We can toggle the editor array. So there we are.
Yeah. On my screen, it looks good.
Yeah, it looks really good for me as well. Slowly drifting clouds. It's lovely.
And also keep it a little bit so I can see it on the screen. Yeah, the clouds are slightly ever changing A little bit.
Just a tiny bit, and that's all you need. You just need that tiny movement in the actual cloud itself, and it almost has that three-dimensional look, even though we know it's not.
Yeah.
Because you've got, as you say, it's almost layered. Lovely.
I was just thinking. I'm just thinking a little bit here, because everything is kind of moving in the same direction.
Mm.
But what we could do is we could kind of make the direction different depending where we are on the screen, if that makes sense.
You could certainly give it a go.
How will we do that, though? I mean, we probably fake it. That's what I would do. As I usually do in these cases. But how would we fake it? Let's see. Okay. I'm just going to fake something here, which has no relation to reality in any sense of form.
Okay, let's give it a go.
So let's try to give a multiplication sign, please.
There we go.
So what I want to do is add movement that is a little bit different depending on where we are on the screen. So things are not moving, you know.
So
what I kind of want to achieve is that sorry, is that it would kind of create like wind patterns, like things are slowly, you know, moving, you know, pixels that are close to each other move roughly in the same direction, but as we move over the screen, they move differently. But we want the overall movement
in the same direction,
in the same direction. But it's kind of on this inside these
inside the cloud areas,
yeah. So I'm just going to fake it, right? Can I give a multiplication sign?
Sure.
What should this be? We can take we just take p.x, see what happens, and the multiplication sign here, p.y.
Very strange.
It looks very weird, right?
Yeah.
That's okay. And what we can do now is we go plus here. Can you give me a plus sign?
There we go.
And we go 0.1 and multiply. How does that look?
Yeah, that's interesting. That's a way to let it develop a bit, really, see what's going on. We've certainly got the general movement in you know, diagonally across the screen, which we had before. It's trying to detect changes within the clouds themselves. So there just seemed to be something perhaps happening in this area.
Yeah, I mean, that looks weird. But I mean, this is just guessworks here, right?
Absolutely, yeah.
Yeah, but what I wanted to get is something that looks
if you look at here, this area here, you do see some movement in different directions. So it looks like these parts of the cloud aren't just drifting down; they're also moving around inside themselves. So it does have an effect, certainly.
Yeah.
But it's very, very subtle, which is probably what you want.
Yes, you don't want it to be overt, if that is the right word, right?
Yeah.
You want it to be kind of subtle, as you say. Maybe if we go back here, We can keep one here, but what we can multiply inside here, we make a const float distortion effector equal 1. And I multiply here. Now my Achilles heel is the multiplication signs. And we get another one here.
There we go.
And a multiplication sign, perhaps?
Yeah, it's yeah, it's I like the movement across the screen. It's quite hard to detect the effect there on.
Yeah, I mean we here it looks too stretched.
That's all stretched out and it's lost some of the nice definition that it had before.
And that's probably because this factor here is so if we instead say plus here, yeah, plus.
Yeah.
I mean, gambling.
The cloud, yeah, the clouds do look. They do look. You see, you can see some. You can see the movement, and as you say, generally in this direction. There does seem to be some.
Yeah.
Rotation or tumbling motion.
The problem is that this factor is always dominant.
Yeah.
Because it's probably we are close to 0, so that's not good. How would you do this? How would you do this? What do we get in here? P.
Yeah.
P. Yeah. We can abandon this, but I'm probably going to explore this later because I kind of like the idea of adding kind of movement where things moves in different directions at different places.
Yeah.
I kind of like that as a concept, although it didn't really work out in this case. But maybe we can keep it. I will keep this idea and see if I can explore it on my own, because I'm not sure I can do it live.
It's very difficult doing things like that live, especially if you
and also
don't think about
because
it.
I don't really see the fidelity of the screen. I can't really see what's happening really, and so it's hard to think on that stuff. So let's just comment that thing out. Oh, sorry, I need to take a quick. I'll be back.
No problem. Okay. I think that's really nice. So, what do you think, Dragon Eye? It's looking good, that, isn't it? So, what we're going to kind of imagine this. Now we're going to, I guess, try and put this together on different shaders. So we get some clouds and our mountains or our sea. Yeah, there's definitely some kind of action going on here, though I think it's more pronounced without this factor on it. In fact, it's interesting. It's nice how the clouds evaporate and come back into existence, because that's exactly what you'd see if you stood up and if you lay down and had a look at it, the sky.
Yeah, you have to know what to do. Is that with regards to shaders?
Well, I think Dragon Eye, if you kind of look back over the videos we've done, I think I've said it a couple of times on stream today. We haven't actually done anything different. We just experimented with different ways of using the same information. So there was height from the Perlin noise, and now transparency from Perlin noise. So I guess if there was other things we could do, we could try those as well.
We can change the noise to the value noise.
That's a good idea. Let's play with the noise. So we're using Perlin noise. Let's go with something else. Perlin fractal.
Hard to say.
Yeah, it's a bit kind of less. I don't know. Something more interesting coming into view now. Let's try a different one. So what?
Value is often good. Okay, that's more intense.
Yeah.
Maybe it's too intense. I think Perlin was better.
So let's go for.
There's also interpolation, which you can if you take the Perlin here. Yes, sorry for interrupting your experimentation. Perlin. That's kind of good. And let's try this. It says interpolation, quintic, hermit.
Yeah, let's try that one. That's kind of softened it, hasn't it?
Yeah.
That's fluffier clouds.
What does that say? Oh, that looks pretty good.
Yeah, so it's made the clouds look fluffier.
Yeah, that is what clouds are.
Yeah, absolutely. The balls of cotton wool.
And then if you pick, should maybe keep one of those. Which one is the best? I can't really tell.
I quite like the linear. Let's go back.
I like the one that comes in here. That system of sort of faint clouds.
Yes, it's really nice.
This calming stream.
So there's.
Dragon Eye. So 1 year ago, I didn't know any of this stuff. What we talk about now. Surprisingly good. Simplex noise fractal. And cellular. That's interesting.
Yeah, cellular was interesting, certainly. Yeah.
Yeah, I think because cellular that makes sense for clouds in my head, because I actually like this. I think this looks quite interesting because it's more intense in areas, and it let's
needs
try
to be dialed back a little bit. It's a bit too intense.
Yeah, but also try these different values here, like cellular turn. I don't know what that means. We can think a little bit here. No, not that one. Below cell value distance. Okay, that didn't do anything interesting. Distance 2. You see, this is what we do here. We're testing distance.
I don't think this one affects anything, so we don't go back to cell value.
You see, it's probably 2, and then Euclidean.
Manhattan.
Actually, yeah. I don't know how it looks on your screen, but here it actually looks. It seems to have a tendency to sort of create bigger kind of systems in clouds, and then smaller systems.
Yeah.
I think that makes sense. What we can do in order to reduce the whiteness of the fact is that if you go up here, no, you're actually right. If you change amp to 45 instead of 5 at line 44. That's too much. I can't really say. You have to help me here because I can't tell. It's a little bit fuzzy, right?
Yeah, it is.
You have to do the experimentation here. This hardcore empirical research. This looks too fluffy to me.
Yeah, it is. Yeah. So that's pretty good. It's still very white in places.
But that isn't, in my head, wrong, really.
Yeah.
Or do you think so?
Yeah, it looks. It looks good. It does look. It looks more like cumulus clouds, something like that. Something kind of.
But it's also interesting to see the different kind of feelings you get by just changing.
Yeah, absolutely.
The noise generation. So if you remove the code, you hide the code. Control 0, by the way, is the shortcut for that.
Oh, I'll just do it this way.
Yeah. And we have still this slight movement.
You can see the slight movement there, which is really good. Yeah, the layering is working really nicely.
I'm looking kind of on the left top corner where we have this like things that sort of fade in and fade out. I like the look of this a lot, actually. I think we can do more. But I think it's also kind of okay as it is.
Yeah, I think so.
Shall we try to integrate that with the with our water?
Yeah. So what I'll do is I brought up code earlier. I'll just grab all this code.
Yeah.
Copy it into VS Code. So we've got a copy
So
of it.
64 lines of code to get a little bit clouds.
Yeah.
That's okay.
That's all there is. 64 lines of code, and you could. It's almost one of these things where you could probably sit here and just watch that for quite a while as a meditation.
Yeah. As with normal clouds.
Absolutely, yeah. Should we bring up the water shader? Should we bring up?
Yes, that's what I'm thinking.
Oops, that's the wrong one. That's our. Oh, so we might as well see this now. This is the.
So I think the ice came out quite nice here. Actually, I think it looks quite good. Don't you think?
It looks icy, doesn't it? It looks cold.
Yes.
I think so. I was so impressed by this.
It looks more icy than snowy,
yeah.
but it's not wrong.
No, that's right. Once you
it can look like that.
Once you get to these heights, it's going to be icy. I really, really love this. I screen captured it and put it as my backdrop on my computer. So.
Yeah. I think, and we can, when we integrate water into this thing, we talk about doing that. I think that'd be very interesting. So let's see if we can integrate the clouds into the water.
Yeah.
Let's see how that works out. I must warn you now, though. I did a little bit experimentation with this before, and I got the clouds to work, but I didn't get the reflection to work. So it might fail. But if it fails too much, we just say, oh, okay, screw that, and then we integrate the water in the.
Yeah, absolutely. Yeah. It's all about experimentation.
So because I do a little bit of experimentation before the stream, not complete things. A lot of things is improvisation, but I want to know that
you
I'm
basic ideas for work,
correct.
Don't you?
Yeah. And here I was like, 2 minutes before the stream, I didn't really. I can't get this to work. It kind of looked cool, but it's not the right. It doesn't look right. Anyway, so what we start by doing is we want to introduce this cloud function here. So you can remove the textures. Sorry. Yeah. You can copy paste the cloud functions. Probably put them below the constants.
Okay.
Yeah.
Okay.
So
get rid of these.
And then we add
the parameter.
Yes, built-in noise.
And then we
512, I believe, was the. No, that's the wrong one. You scroll down.
There we go. That's the one. So it was 512 by 512. We called it texture 0.
And this is white, and we don't want white. We want something else.
Yeah. Then we want Perlin noise. We wanted. Oh, what was it? It was cellular we chose, wasn't it?
Cellular was the last one we take place.
Yeah, cellular. And then we want to say these are repeat. And these were linear.
Yes.
And I think.
Yeah.
I think that was it. Save that. Okay.
So we can start with the sky first. See if we can get that to work. Like I said, I failed miserably with the. So let's see if we can get the sky. So what we do now, we have the sky color, but you see we have a water plane, but we're also going to introduce a cloud plane.
Okay.
That is high above, kind of. So we do the same thing here. So if you scroll down the code, scroll down, bottom. So you see you have this code here to see.
Yeah.
So this is if we intersect the sea level. Now, what will happen now is if we don't intersect the sea, we will intersect the sky.
Yeah.
And then we just return where we're pointing at.
Yeah.
But what we want to compute now is the height, is the distance to the sky.
Okay.
So you kind of do the same thing here. Yes, you can do it like that. Distant sky, and then you can give a height to like 1000 perhaps. Just a number, whatever.
Yeah.
Minus, same thing. Divided by
The way direction.
link slumps. Hello there.
Link slumps, welcome. Haven't seen you for a while. Welcome to the stream.
And if this guy, and then you make an else if here, right? Or you go else if this guy is less than or greater than 0. That means that we intersected the plane, which is everywhere. That's good. That's okay. So you just copy sky call here in there as well.
Okay, yeah.
Even now I'm working on an assignment at the moment in C.
Oh, you got the right. You got the right person on stream then, with Mårten.
Well, I know C++, but I know a little bit of C as well. It's kind of C is not really a complete superset, but it's kind of a superset to C.
I did C programming many moons ago. It's in the dim and distant past. So the shader language here, GLSL, is sufficiently C-like that it's easy to use.
It's very C-like. But you do away with everything that is boring.
Yeah.
And that is recursion and allocating memory. We don't do that here. So that means we can focus on the cool stuff in life, just pure math.
And that's what we want.
Yeah. So if this guy is bigger than 0, then we can compute a position in the sky. And what you do then is you'd say say vec3 p equal the ray origin.
Well, we can't use p, can we? We'll use.
Yeah, but we are inside the else,
okay,
so we can.
Ray origin,
in C you couldn't do it, but here we so. And if plus this guy times RD. So now we get the position in the sky.
Yeah.
Almost like a Beatles song. Loose in the sky.
Ardo plus this guy times RD, yeah.
Yeah. So that's good. Then we can sample the clouds that we had going there. So then you can say vec for clouds. Or cloud or something like that. Yeah, clouds was the function name, so perhaps that's not so smart, but okay, it doesn't matter. Clouds. Yeah, clouds called. Yeah, smart. We did that. Yeah, and then you send in p.xz, comma 0.
Comma 0. Okay, we did have a factor in there, didn't we?
Yeah. So that is the clouds color. So what you do now is you use the mix function for col equal sky col, but instead you say mix, comma clouds xyz. I'm guessing now, by the way.
Okay, I think I can remember.
Comma clouds w, and we will see what happens. Probably going to look crap, but doesn't matter.
Okay, so we need to do something with that, but we've got something appearing in the sky.
It looks very odd, right?
Mm-hmm.
But the reason for this thing is now we it's very noisy, and this is obviously not how clouds look. So if you multiply this position by 1000, perhaps, see what happens. Does that go in the right direction? That's a little bit more. Or is it going the wrong direction? Yeah, right? No?
Yeah.
Yeah, it's probably in the wrong direction. So you say 0.1 instead.
Now we're getting there.
Yeah, more.
Ooh.
that looks interesting,
Yeah.
don't you think?
It's that cirrus cloud, that is, isn't it?
Let me borrow this thing here.
Ooh.
Okay. Let's start time. See what happens.
It's certainly interesting.
Yeah.
It's too quick, but we've got to be careful, haven't we? So.
Yeah, but
the horizon looks wrong as well.
What we should do here is the problem is that we get too much, in real life, there's a curvature on Earth. We don't have curvature here. But what we should do is that when we move away, further away, we should tone everything into the background noise.
Yeah.
So that is what we should do, and we can do that. But how should we do it? Okay, I'm going to write some code here.
Yeah.
See how it works out. So we go float a equal arctangents. Is it? I forgot. What said? So this is to get the angle between the ray and the sky, kind of.
Okay.
No, we need RD. Okay. Like so. And I'm going to say, is C89 a version of C? I think there's a C99. There might be a C. There might be a C. What's it called? 89 as well, but I don't remember.
They're all very old, whatever. I don't think C hasn't really kind of progressed. I don't think. C89. Well, I think most of the kind of developments in kind of the C world have been with C++, so you're fine. But you don't want to do it anymore. You're not enjoying it. Well, say it's for school though, I suppose, is it? So you've got to, but yeah, just got to work through it, and then you don't have to do it forever.
So what we did now here is that I took the angle, which is the angle between the ray and the sort of horizon. So the horizon, the angle is 0 then.
Yeah, so it's gone dark there, yeah.
Yeah, and then it goes lighter. So, and this thing then enables us to do mixing, because if it's 0, it should be the sky col. Otherwise, it should be the col. Now, it doesn't look right, but when things don't look right, we use the power function.
This is the trick we've learned before. Just put a large power
function
in
is very, very good. I love the power function. So when things don't look right, you just try it a bit. Is it here? 1.0? Yeah?
Yeah.
So we want to push the values towards 1. So you go 0.5. Yeah, that was an improvement.
Yeah, that's it, yeah.
Okay. Well,
I think that was fantastic.
Let's do remove the code.
What do you want to do, sorry?
Remove the text.
Oh, remove the code, okay. I'll just save it first.
Yeah, of course. Always save.
And then we'll just toggle the editor out.
Yeah, I mean, yeah, I actually agree with you. It's an intense cloud.
It's quite some cloud cover, and of course we've got an alien sun here, which is huge and burning its way through the cloud. But it certainly does look. It looks really good.
I mean, if you would ask me, what is this? I would say these are clouds.
Yeah. I really like it.
Yeah. is it coming in a sort of not so dense area now, right?
Yeah,
It
so
looks like
there's some kind of holes in the cloud here. It could do with being a little less dense, I think, would be my preference. Because it could do being a bit more wispy in this. This looks very kind of summery, pretty calm, isn't it? So it could do with being a more kind of cirrus cloud rather than this
yeah. But
dense cloud.
let's time to let's put back the code. So you can change this multiplication factor here with something else.
This one here.
So if you remove a 0, see what happens.
Yeah.
So
that's very cirrus cloud, or
yeah. If you change the 5 to 2.
Oh, that's even better. That is very natural looking, actually.
Yeah. It's not bad, I think. Right? I mean, once again, considering the effort we put into this.
Yeah, virtually none.
What we can do also is this thing here.
Oh yes, our distortion factor, yeah.
Yeah. So let's. I'm just gonna.
Ooh, that's interesting.
That's weird. Not what I wanted. If I go, I think tan H is a very useful
but
function.
hyperbolic tan action, yeah, I like that.
So I learned a few functions, and they're useful because they have certain behavior. Yeah, that's weird.
It's very strange how we've got this line appear down here now, isn't it?
Oh, it disappeared.
Yeah. There's some cloud around.
We go 1 0 minus.
So hyperbolic tangent, of course, is it's linear around 0, but as it approaches plus or minus 1, it tails off into, it never actually gets there. So it's a.
I think it tails off to 1.
Yeah.
And that is what's good about it.
Yeah.
So it's linear around 0, and then it tails off, and it kind of goes towards 1 asymptotically.
Yes.
Yeah, that word. Multiply or something nice here. Yeah. So.
Ooh, that's nice as well.
I'm not saying this is the best, but so what happened? The reason I'm using this tan thing here, right? Because as Z goes towards infinity, I want the clouds to kind of disappear, because otherwise they kind of become very high frequency in the distance. So that's why I'm experimenting with this thing here.
You can see they're faded out quite nicely, actually, haven't they?
Yeah. So when it's close to us, we want it to be intense, or as intense, and then when it goes to infinity, we want it to sort of fade away. So that's why we are using all these kind of mathematical functions very scientifically. So if someone would look at this, think, oh boy, they have really been thinking hard about this tan hyperbolic tan here, right? No, we didn't think at all. We used hyperbolic tan, at least I used that, because it has this thing around 0, it's linear, and then it goes towards 1.
Once again, I used to use it in the audio programming as well, because that's kind of behavior you want. You always want your values in audio programming between plus and minus 1, and you want a nice linear response around about 0. But you never want to hit actually 1 or minus 1. You want to just get infinitely close to it, but never actually reach it.
Yeah, so it's just a brilliant function. It's a very, very nice function. So these are the things you learn when you're doing these things, that this function has this behavior, and this is what I want, and So you have this toolbox of functions that you just know they behave nicely. And same with the power function we talked about before. Why that is so good, the power function in like we used here, is that if you go power by 1, that's normal. But if you go power 0.5 or 0.2, then you try to push the values towards 1.
Yeah.
So values that are closer to 0, they get pulled more towards 1.
Yeah.
And the same thing when we go power by 2, then you try to push values 0 close to, yeah. And that's very useful occasionally to kind of create the different kind of dynamics in the scene. So you just power and you test with 2, no, wrong direction, 0.5, yes, right direction, looks good, keep it, very scientifically. Of course, we are inspired by math and sort of use like reflection functions. But when you do these kind of shaders, you can read about an effect like the Fresnel effect, and you read about these effects that exist in real life. But when you implement them correctly, because it's not really, this is not real. It's an approximation for real. Then it looks a little bit strange. But then you tweak the parameters, and then you get it to look right, even though it's not real. I mean, it's not a real math function. But that's okay, because the purpose, I think, when I do shaders, I want some real-time ray tracing that looks nice.
Yeah.
Screw the whatever cheat I had to do to get there. I don't care.
And you want it as cheap as possible, as you say. These are relatively. I mean, for our GPU, it's not going to be have a problem with any of these.
I actually think this looks surprisingly good.
I think it looks really good.
I'm surprised. I'm actually surprised.
Surprised yourself, have you?
Yeah, because I was experimenting a little bit before, but it didn't look as good. This is well.
But it just shows you can sit down and try to do the same thing in 2 different streams, or at home and on the stream, and you never really know what's going to come out. So that's another part of the joy of the shaders, I think, really.
And I also find it helps a little bit for me to explain these things.
Yeah.
Because then I do things a little bit more carefully than what I normally do it. And then it actually turns out sometimes a little bit better. And I do it differently than I did before.
Yeah.
Well, shall we try to integrate this then with the big one?
Yeah, okay. So what I'm going to do, again, I'm going to copy the code into VS Code. So we've got all the bits and pieces of this.
I think this you probably should put on Shader Toy.
Yeah, this will go on Shader Toy. I've got to figure out with the Perlin noise bit again, or the
noise. That's the problem. Yeah.
But we'll give it a go and see what happens.
Yeah, whatever. It might not look as good, but it doesn't matter.
But it'll be up on GitHub as a Kodelife project anyway, so people can download it.
So Dragon, you wonder what I had the problem. The problem was when I tried to get the reflection of the in the water to sort of get the reflection of the clouds. It looked cool, but it looked more like Sauron's eye from Lord of the Rings than it was supposed to look. So I mean, it looked cool, but sort of in a nightmarish version of cool. And I couldn't get it. But the thing is, the clouds, how these clouds look, I think this looks okay because the sun is kind of the brightest thing in the sky.
Yeah.
And that is what you see in the reflection in this particular way. And the clouds, you don't see the reflection because they're kind of outshone by the
sun. Yeah. And anyway, it's not a mirror surface. It is rippled surface, so you would be unlikely to see. You don't often see the reflections of the clouds in the.
You can see it certainly, but I still think it looks okay without
definitely.
It looks believable, and that's what we're going for: believable ray tracing. And also remember, what we've done here is very cheap, which I think is quite cool.
Yes.
Because we intersect the plane and then we compute the normal. And then we intersect the sky, but we also intersect as a cloud layer in the sky. These things we're doing is actually very cheap, comparably. So this shader, which I think looks quite nice, especially in the top corner.
Yeah, it looks great up there. Yeah, so I think it's just.
If you put it on Shader, I think it's going to run completely fine on even quite modest machines.
Yeah.
And this is great news, because when we want to integrate that with the big shader, that is very costly. We don't want to add. We want to add cheap clouds, and we want to add cheap water.
Yeah.
So we don't go over our budget in teraflops. So that the purpose of this thing here is actually to produce a shader that looks nice, but it's quite cheap to produce.
Yeah.
The results. Because when we are ray tracing these mountains and all these kind of things, and it's costly.
Yeah. Let's go over and get the mountain shader up then. I think it was 6. There we are. I'll stop time.
Yeah, stop the time.
Go back.
Yeah. So shall we try to add the clouds first?
Yeah. So this is going to be interesting. So I'll grab the cloud functions we had, which was it was clouds and noise, wasn't it?
Yeah.
So cloud, col, and noise. So pop them in below the constants again. So interesting enough, the texture here will be the same texture we had before. So
we need a new texture.
Need a new texture,
because this is the mountain texture. Because we want to use the cellular thing.
Yeah. So let's have another.
What happens if we change the mountain to cellular here? By the way, how does the mountain range look?
It was this one, wasn't it?
Yeah.
Ooh, look at that.
It looks weird.
Yeah, it looks very strange.
Yeah, so Perlin noise is probably better, I think, in my opinion.
I think so.
But
there's other things we can try. There's lots of different things we can try. So, I mean, yeah, just download it yourself and have a go. But I think we settled on Perlin noise for this one.
Yeah, I think Perlin is good here.
So we're going to add another parameter here, aren't we? So where's parameters gone? There they are. Parameter, built-in noise. And let's see if I can remember all these bits. So 512 by 512. I'm going to call this texture 1, I suspect. Then we had cellular, repeat, and linear. I think that's all we did.
Yeah. And the change from texture 0 to texture 1, right?
Yeah, texture 1 here.
Yeah, but in the function as well.
Yeah. And our noise is going to be texture 1. Okay.
And then you scroll down. And now we're going to introduce this thing here. So where we are computing. So this shader is obviously a little bit more. It's a little bit more.
Yeah, so this is get col, I think, is where we want to be here.
Yeah, in get col.
Yeah.
So but I think we can compute it. We can compute it. Yes. I'm thinking loudly. We can probably compute it quite early on here. So if you remember, you did the sky, the clouds, before.
Yeah, D sky. So that's this one here. So so we could put D sky. Where did we do DC? It was here.
Yeah, so
we can do D sky into that. I think we'll remove the ambient thing.
Yeah.
Okay.
And then you go down.
We want to. So we've got an if, an else. There's the snow. So where exactly? So we're going to want to put in.
Let's go. I'm looking for where we return the sky color.
That's here. Do we want an else if in there then?
So where is the sky call? Where do we compute the sky call? Oh, probably here, right? Okay. Let's try that one. Let's change that to black. That color. Where you were.
Here.
Yeah. No. This doesn't work. No, you're right. Look. I was gonna scroll around a little bit here.
Okay.
It was some time since we wrote this. I kind of forgot.
And it is quite a beast now.
Okay. Where do we compute the sky call? There. Okay. D is less than D. Oh yeah.
Yeah, you've got the trees and the snow, the fog.
Yeah. So now I remember a little bit here. It's coming back. So we put this guy inside the thing there. Yeah. So what does that say about Norway? Maybe it's computed by cellular random. So random noise. So if you cut 292.
Okay.
And let's go outward. More down. More. Here, return sky call. So now we are going to do the kind of the same thing we did with the clouds before. So you can probably copy paste that code. The clouds.
Yeah, sorry, I'm just going to sort something out here. Okay, there we go. So
yeah, we can probably remove that part, right?
yeah.
Can I borrow the color?
Yeah.
Move this thing here.
Return call, yeah.
And then we can say Vec3 call equal sky call, just to try something.
Oh, there you go.
Yes. So the problem here we're having right now is
it's the same problem we had with the water, isn't it? So we just
the problem is it gets too intense over here, right? The frequency go up. So we want this to sort of fade away. But another way we can do fade it away actually is if we go here, use this thing here, and you can have a multiplication sign.
There you go.
And yeah, can we copy paste this line up here? And this
line here.
No, yeah, there, right? And put that in the parentheses below.
There we go.
Okay. Okay, is that good or bad? Yeah, so it's kind of good, but
yeah. I think also the sky height, the sky is too high, but
sign?
Oops.
No, that doesn't do anything. Okay, that's something.
Yeah.
Let's start the time.
I like that cloud there. That's really nice, and the way it blends into the colour of the sun as well. It's really nice. We just need to lower the clouds a bit.
But the clouds aren't moving, or are they?
I think they are moving. They're moving very slowly.
Yeah.
You can see this cloud here is moving. You can see it's moving in this direction.
Because you would expect it to kind of move towards us, right?
Yes. It's moving that direction rather than coming towards us. So we need to rotate the direction of the cloud movement, I suppose, don't we?
Yeah. So I was kind of.
But I mean, even just that basic change looks really good.
I'm going to try something.
Okay. Mm-hmm. Nice. It's got some weirdness going on near the horizon, but
yeah, but that's okay, right?
Yeah. Bit to the left, bit to the right, yeah. Oh, that's nice. Oh. Yeah, it's incredible how you just change these values and you get complete. That's nice as well.
And I would see it on the screen now. Stream now.
If you look up on this one,
I like how they interact
nice.
with the sun.
Yes, it's very nice how they interact with the sun. Very natural
and also,
looking.
Also, what's good about when you add this cloud that kind of covers the sun, it's give kind of now we know it's not anything to do, but it gives kind of this explanation model to why it's differently, why some areas of the ground
Yes.
is more intense than other areas, because there we have a hole in the cloud that shines directly through it.
Well, I think those really bright highlights in the trees really make this shader.
Yes.
Apart from the wonderful ice reflections, just that odd, really intense reflection or highlight onto the trees is.
I noticed it gets too much sometimes.
Sometimes it does, but even then I don't mind because there was
but it goes blue.
Yeah,
I mean,
I
it
suppose
goes
so. Yeah.
way too much.
Yeah.
But we can clamp that.
Yeah.
I don't think this looks half bad. What do you think?
I think it's really great, and I really like the way that it's faded into the horizon now. We don't get that really weird line, and you've also got some nice misting on the horizon anyway, which is making it look really quite natural. I'm going to save that.
I should do that.
It's really good.
Yeah, there's kind of a rolling movement as well in the cloud
Yes.
that kind of makes it looks believable.
Because we are flying along as well, so we're not on the ground, so we're up quite. We're not near the clouds, but you get that movement, as you say, that you are rolling underneath.
And here we have an interesting cloud complex.
Yes.
I think. And now this cloud complex above our head is kind of disappearing. That's not bad. Could be much worse after 3 nights.
Yeah, absolutely.
Shaded away. Yeah, save this. commit it in GitHub, Git, and we don't want to lose this.
No.
Yeah, but I actually think this clouds looks pretty good. Surprisingly good, because when I see sometimes cloud people as in shades, I often think they look. I think this looks better than many of them. I mean, I don't say this is the best clouds I've ever seen, but I think we don't have to feel ashamed.
No, absolutely not.
It's not a competition, but you don't want to end up last, is what I always say.
Okay, that's all safely up on GitHub then. So,
and now we have kind of in a new kind of clouds coming back.
Yeah, that's the thing. That's the whole thing about this shader is it evolves and it evolves in really interesting ways.
Yeah.
And one of the kind of weird things you start to get as time increases, you start to get these parallel lines in the
yeah, but that's because I think that's because your precision runs out.
Yeah.
And I think we can fix that by adding a modulus, so it's kind of kept into values. But then at some point there will be kind of sharp. But we can fix that probably, right?
Mm.
But these parallel lines, they come from this thing that that's okay. I think we can fix it, but it's not too bad, right?
Oh, it's coming across some interesting part of the shader now, but much more mountainous here. Look.
Yeah.
And the clouds look wonderful, I think. So I'm really, really pleased with those.
Yeah. Yeah, I think looks pretty good. Shall we try the water?
Let's give it a go.
Yeah. So let's reset from the beginning. So, yeah. I need to get some water. You can,
okay. I want to get a drink as well, so let's put some. Be right back. There we're back again. So let's just refill the old cup. It sounds like Mårten's still getting his drink. Get some water and pour it on the keyboard. You get water in your shader tool, yeah. Yeah. I'm always constantly worried about knocking drinks over. I've seen it done a couple of times on streams.
What to talk about now?
I was just saying I'm always frightened of knocking my drink over while streaming. I've seen a couple of people actually do that on stream, and it's a bit of a nightmare with that. So I'm really kind of trying to be very careful.
Yeah, I've only ever done it once actually, and then I had a laptop with a replaceable computer, so I was lucky then.
Oh right, yeah, that's good.
The replaceable keyboard. It was just actually to lift out the keyboard and put a new one in. The keyboard was crappy, but at least that part was good.
Yeah.
So that was very simple to fix. Now it's a very common problem at work. We have these new MacBook Pros. They're not new anymore, but they were new. And the keyboards are just breaking apart, left, right, and center. The space bar stops working, the tab stops working, because it's very sensitive to getting dust under the between the key and the rest of the Mac. So, but these things, you can get it on warranty to fix it, but then the computer is away for 2 weeks.
Yeah.
Because everything is glued together, so it's a very complicated procedure to switch the keyboard. So people say, screw that, and then they get an external keyboard and write on that instead.
Yeah, I do worry about kind of the Mac things. They're so expensive, and really, when you're kind of spending that kind of money, I think you're going to want to have something which is going to stand up to some use. I've not used a Mac personally, but
I mean, most laptops are expensive.
yeah,
But I think the Mac is a very decent computer, but the keyboard on the new Macs are I'm not a fan. And also this should not be a Mac hate stream, but I use the Mac for work, right? So it's good. But the keyboard and the touch bar, I'm just foreseeing a future where the touch bar, it will just be a touch bar on the keyboard and nothing else.
Yeah.
Like a screen.
Yeah.
So that's my nightmare vision, because then all tactile feeling are gone, and it's like you're hitting a glass with your fingers.
It's like typing on my iPad Pro. There's nothing
like
to
that.
it. Yeah. So that's why I've gone for kind of my work keyboard upstairs is a mechanical keyboard because it's okay to use that upstairs. But I've got a kind of a pseudo mechanical keyboard for the stream, so it's got a good tactile touch, but it's not so noisy. It's not so clacky as a true mechanical keyboard.
I guess you use this classic spring keyboard, right?
Yeah.
I have blue switches on my keyboard, so that's a little bit easy, but not so bad. Anyway, so keyboards, but good thing with these gamers, because we really had really rubbish keyboards for a while.
Yeah.
Really bad. And then these gamers came along and demanded good keyboards for their Counter-Strike and they're playing. And then we got good keyboards back.
I think Dragon Eyes hit it on the nail on the head there with the original IBM keyboard for the IBM PC was phenomenal.
A Bacca Spring, I think it's called.
Really good. And they've kind of brought out some clones of it which are nowhere near as good. They're not IBM ones. They're just people who are trying to bring out, something which is reminiscent of the IBM keyboard. But that keyboard was phenomenal. Really, really good. My first job, we had IBM PCs to run. I used to work in infrared spectroscopy, and all the results of the spectrometers were fed into onto 5 1/4-inch floppy disks and fed into an IBM PC. And I used to love using the keyboard. It was great.
Yeah. But then, for some reason, after that, a few years later, we got these horrible keyboards.
Yeah.
Really bad. But at least now we're back to something that is, I think, acceptable.
And they're coming down in price, these mechanical keyboards as well, so you can get some decent ones.
Yeah. So I guess that maybe that was probably the IBM when the price of computers fell. You couldn't afford it. But if you just look at the C64, I think that keyboard is better than most rubbish that was out on the market a few years ago.
Yeah, I think you're right. Yeah.
So and that was intended to be a cheap computer for kids, right?
Yeah.
So what? How what it is? SMB, everything was better before.
That's it. Everything was better before.
Yeah.
Everything's worse now. That's good. We take that for granted.
The further back, the better.
Yeah. So in Stone Age times, their computers were really good, and their keyboards were phenomenal.
Yeah. So. But so I started programming in the 90s for real. But the good thing about the computers on the 90s, then the RAM actually kept up with the CPU.
Yeah.
You didn't need caching. But now, these days, this RAM memory is so slow. And it's actually kind of misnomer sometimes. It's more like a SAM. Sequentially accessible memory, because if you try to access memory randomly, it's not as bad as a disk, but it's super slow.
Yeah.
So, but when I used to program like with the C64, then the memory actually was kind of good. It kept up with the CPU.
Yeah, the CPU was so slow.
and that was actually called it's called something. What's it called? Von Neumann bottleneck.
Yeah.
And that was actually foreseen already in the 70s. That would happen because of the von Neumann architecture. So, and what we do to fix it is add caching and more caching. So it's crazy. Anyway, water. Okay, so I think what we can do, Let me try something. Can I borrow a screen?
Yeah, all yours.
Yeah.
I'll just ask the bot about the von Neumann bottleneck. So there's something in chat about it if you want to read about it.
Yeah, von Neumann architecture sucks. That's the only thing we have to keep in mind. Yeah, so here we computed normal. Ref sky color shade. I think we kind of comment some of these things out.
Okay, I'll do it for you.
No, oh yeah, do it please. And
there.
Yeah.
Do you want me to comment that, do you? Okay, you do that.
I just want to remove it.
Okay.
I need a it's called curl bracket. Wrong direction.
Yeah, got it.
And we can change the C height to I don't know. No. Okay, that wasn't right. That isn't definitely right.
Are we using C height anywhere? Oh, there we are. There's some C.
Yes. So now the normal here, that's not what we want. Now we want to compute the normal. In order to compute the normal, we need the function you remember in the old one, where we computed the C height to the normal from the C height.
Yeah.
Yeah, okay. I guess I should have English keyboard, but I want to involve SMB, right?
Absolutely,
so,
yeah.
And so that's my excuse. So we can get that thing. Yeah.
Where would you like to put it?
Yes,
there.
Above where we use it is the most important thing.
Close to where we're going to use it. Okay.
Yeah.
So it can be
just above. Yeah, doesn't matter where it is
really. Where were we?
Over the get color function. We're going to use it.
There we go. So we got our C height function.
Yeah.
With our gravity wave, etc., and then our C normal function.
Yeah.
Oops, and that's
and
it.
Then we need a gravity wave.
Gravity wave. So we do. That's this one here. And I'll get the constant in as well, but I'll put the constant up near other constants. Gravity constant. It's just one at the moment anyway.
It might have that Dragon Eye. I haven't really used it. You can import mouse coordinates. So it's not impossible that the shader actually do have coordinates to do so. But I haven't really experimented with that. If you implement a shader like using WebGL in a web, you can most definitely have being controlled by keyboard.
It's interesting you say that because there is mouse input, as you say, but we've not really even looked at that kind of thing. So
what we could use the mouse to sort of turn around the camera, and that's sometimes useful, but I never really use it.
Okay, so we've got our C height and C normal with gravity wave. So C normal, we need to put in P and some float D. So do you want to count the C?
So the normal here should be the C normal.
Yeah.
And the P position is okay. Yeah, and this has to be. You have to move it below the row 321 because you need the PC.
Yeah.
And then you put in PC XZ.
And then we've got a
D.
D.
Yeah.
Yeah.
Okay, that didn't really do any difference. That's okay. Can I borrow the keyboard?
Yeah, all yours.
Okay. Multiplication sign, please. I'm like a doctor, like to say. I was kind of hoping to see some ripples.
Yeah.
Something happened there, at least.
Something's happening. It's hard to see what it is, isn't it? Some ripples coming in now.
That's something, at least. Right?
Yeah.
Is it smaller or bigger?
The larger, the more effect you're getting.
I think you need to sort of find a level that is working here.
There's certainly.
Let's go forward. Let's go forward a little bit. So let the mouse so find some place where you have a lot of C. Ah, there, good.
Yeah.
Okay. What do you think?
It's very linear.
Yes, it is linear, but other than that, are the
we see you got nice ripples here.
Yeah. Let's
Maybe
experiment
with
the different.
Ooh, yeah.
That doesn't. Or maybe 200 was quite kind of good. Help me out here.
What was it? Just increase it slightly for me. See, that looks okay to me.
Okay. Yeah. Okay. What we can do in order to maybe break it up a little bit is that we add a little bit rotation to these things here.
Okay.
It looks too regular, right?
Yeah. Yeah. Oh, yeah. That looks interesting then.
This experimentation.
Yeah. I think it's getting there. It's hard, isn't it? Because it's getting better, but then you've still got the regularity there. Oh, it's getting. Yeah.
You see, the chat sees here now the enormously. A bit too big, perhaps.
The ripples have to move the same way as the clouds. Dragon Eye. Yeah.
A plus sign, perhaps.
Okay. Yeah, it's difficult, this one, isn't it? Because in the previous shader, it was very much waves coming towards us, and that was quite natural.
Yeah.
But here we've got, maybe we've reduced the size of the bodies of water, actually, maybe so we get some, so there's maybe less of it. Oh, that.
Can I get?
What would you like there?
Go back to plus sign.
Oh, okay.
Yeah. But if we
No,
multiply
this is looking interesting because now we've got kind of sparkling on the water. It's very obviously it's too intense, and too dense. But yes.
Let's try and multiply that by a number.
Ooh. No, it's getting there, isn't it?
So the idea here was sort of to kind of change rotations. That was weird.
Yeah, it's strange how it looks really good close up. And here we got, yeah.
But the thing, what happens in the distance, we can always reduce that thing.
Right.
I think it's a little bit an improvement. This thing over here, what we can do is we can make sure that the normal here kind of is. What we do with the normal is that we kind of sort of move that. What should I say? We reduce the noise level.
Yeah.
Of that thing over there. That's doable. The important thing is that the thing that are kind of close to us kind of looks at least somewhat believable. At least it changes a little bit now.
This probing effect and the lines look weird. Mind you, there's a lot of water at the moment. We need to reduce the sea height so we get some greenery.
But the strobing effect we can, I think that we can deal with. What we want to break up is kind of the regularity, if you see what I mean.
Yeah.
So I'm gonna do another these common techniques. If you want something that's pulsating back and forth,
yeah,
sine is good. Oh yeah, let me go.
Yeah, it's interesting. See, it's almost yeah. That's getting very close, I think.
Yeah.
That effect there, I don't know what it looks like further back, but obviously in the distance it's overblown, but you get that kind of sparkly effect.
Let's try this.
Interesting.
Yeah, it is a little bit hard finding a good. I'm gonna look at my my Magnum Opus shader, see if I have some good ideas there.
Okay. Deeper valleys for the water, yeah. So I think
the reason we kind of have it there is we want to sort of see it kind of clearly.
Yeah. So we will lower the water, I think, so we get some of our lovely forests in.
Yeah.
Forested edges of the water. But we
But
need to be
first,
able to see it at the moment, yeah.
yeah, first we need to see it kind of, and we also need to add shadows, and there are many things we want to do. But I think probably what's the most tricky for us to do is getting the we don't want it to look like this regular pattern that distracts from the believability of everything, right?
That's exactly, yeah, because the rest of it is looking absolutely awesome. I mean, the clouds look fantastic, and we've already got some really good mountains and snow and stuff. So,
how the heck did I do my waters? I was struggling with that as well.
yeah, this is hard, I think, this, because it's up the kind of test shader we did with the water. From that point of view, is relatively simple. It's waves coming towards us. Here we've got a much larger body of water. We're elevated position, flying over it, and it's a harder issue because I'm not even sure what it would look like in nature. Just I get the impression it would be the sparkly effect is almost what we want, but it's just too much. You can see over here it's just basically random noise here, but almost here it's starting to look, like in this little inlet here and around this headland, it's starting to look right. But when you get close here, the sparkles are good, but then you get these regular shapes, so it's difficult.
Yeah, I see. What I did here is I did something. It's not easy when it's hard. What did I do here? Angle. Yeah, I did something. Do you see any difference when you do that?
Yeah, it's not really. It's oh,
Let's
kind of
increase
starting to rotate.
That's weird.
So it's starting to have some interesting effects. So now it's just like circles, but you can see the rotations are in there.
I added transpose here as well in my old code. What is that transposing thing doing? Oh, yeah.
So that's getting close, I think, isn't it? That water is now.
So let's see if we can add something to the position as well here. So that we don't just. Can I get the plus equal? Where is the transpose? Where the variable come from? FR. Yeah, so I'm looking because I was experimenting a lot with these water waves to get them kind of okay-ish. Where is FR defined? I'll look at my old code here.
The Dragon I was talking about putting some noise texture in there, but the noise isn't a texture as such. It's just like random points, I guess.
Ah.
So maybe you could do that.
Okay. Let me see. Yeah.
See, I'm looking at the little kind of preview picture at the top, and there's some very nice effects from a distance, but close up it's just too regular. It's getting there.
Yeah, it's like square-ish kind of shape.
Yes, it almost needs to. Oh,
that's better.
It is better. Yes, that is a lot better.
Because this looks better. it's just it's silly the change we did. Yeah, this looks a lot better.
Yeah, I think it needs to be Does it need to be smaller? You see, that's really nice because it's starting to pick some of the sparkles, the highlights on the waves, isn't it?
Yeah. So what we can do here is like you say, I think the waves maybe need to be smaller. So where is this multiplication for the wave? Is something down here, right? Stop. They become bigger.
They become bigger, yeah.
How does it look now?
Let me just hide the editor for a second. What do we think, guys? I mean,
It looks regular.
It looks regular, but it looks more natural, yeah.
Yeah, but I think what we can do to make it less of this regular pattern is that we are going to it also the thing is we don't have shades on this thing here.
No.
That distracts from the reality. And we also don't there are many things we're missing that are distracting from the impression.
No.
Do you think?
I think it's getting there. Let me just hide the editor again.
Yeah.
Yes.
So the thing we can do to break the irregularity is we can change the amplitude and these kind of things.
I think that's looking a lot better.
Let's continue, and we can come back to this and experiment when we have other things as well.
Okay.
So let's reduce. Where is the C height?
C height's here on line 318. Should we fly and see what it looks like?
Let's try it. We need to add shadows and these kind of things, but let's see what this looks like.
Doesn't that look cool? We've got forested islands and everything, haven't we? Now
it's getting there, I think.
Yeah, definitely.
There was good hair with the shade there. So what we're going to do here is, what is this? Is the F1? Yeah, that makes it go more. A multiplication sign.
Ooh, yeah. It's funny because it starts to look really nice in the middle, and then as it comes to the foreground, it's perhaps not. Let's just have a look at toggle the editor out of the way. I don't know though. Probably still want less water.
Yeah, but we can experiment with this because I remember it looked this fun as well. But when we add other effects to it, so it's not as evenly colored.
Yeah.
Let's then. What do you think?
Yeah, it's nice. Yes.
Okay, I think we can keep it like this for now, and then we're going to add the other things that we haven't added yet, right? Because we had this refraction shading, if you remember.
Yes.
And we need that as well, because that actually adds a little bit to it. So let's see now. Can you get that part of the code where we had refraction? We compute that somehow. The refraction is that the more flat it is, the more reflective it is.
So I'm just trying to find that piece of the code. So I'll bring over the Visual Studio. So is it this where we do all this normalization here? Is it this here?
No, that's that part is
reflected sky color, reflected ray.
The dot product then.
One here, is it? Dot product.
We need a dot product.
Yeah, I'll find where that is.
Yeah, it was
down there, was
2 lines above it.
Oh, there it is. Yeah. Where would you like that?
Put it after we compute the normal, perhaps. And then we do, and then you go back to the Visual Studio.
Oops, that's the wrong thing. This is what we want. Then we've got reflected sky color.
Reflected this thing here. This is what we want.
These two.
No, this thing here.
Just that one there.
And we want the whole mixing thing.
Oh, the mix as well. Okay.
Yeah.
Okay.
Can I borrow it? Yeah, you copy paste it in here somewhere. Under here.
Okay. Okay.
So what this thing does here.
Oops, sorry. Trying to help you out. Okay.
What ref sky color. So what this thing does here is we take the dot product, that is, we compute the angle between the direction of the ray we're looking at and what's called and the normal of the sea.
Yeah.
And the more they are kind of orthogonal to each other, the more reflective the sea becomes. We can actually see that when we go outside. So when we're looking down into the water, it's actually going to be more
less reflective. Yeah.
Yes, and we can use that. I think we might see an improvement or a reduction. Yeah.
Oh, I think that's definitely an improvement.
I think this is an improvement because it looks less evenly colored as before, right?
Yes.
And we can make it even better. So let's start by seeing. So let's scroll here and see what happens.
No, that's definitely an improvement.
Yeah, because we see that now the reflection highlights disappear when we go over it.
Yeah.
And I actually think it's actually, it's not perfect yet. But I think this did a difference.
Yes, definitely.
It looks more like water because now when we're looking into it, it becomes more black.
Yes.
Like you would kind of see water. When you look into it, it becomes more black. So I think this simple change actually did a quite big difference.
It did, yes.
So, and also because of this regularity of the water becomes, it's not gone, but it becomes less. It stings the eye less.
Yes, I think you're right. There's something about it previously which was just like annoyed you, wasn't it? It's just something about it in the back of your head that thinking it's not right.
It doesn't seem right, but now because the water kind of changes. Now, what I want to do as well is if the water here is kind of close to coast.
Yeah, we want some reflection there, don't we?
Then we could actually
With some shadow.
make us see kind of see a shadow of the
trees,
of the mountains, not the tree. We're gonna add the proper shadows later, but we here it could actually be that we could see the sea floor.
Yes.
But when you go down here,
it's too deep. Yeah.
It becomes absorbed by it. So that's kind of what I want to go for. So let's see how we do that. So let's bring up the code.
Right. I'm just going to save before we go any further. Okay.
Now I'm thinking. That's always dangerous.
It's all right. Don't worry.
Yeah. So we can say vec call sea floor, and that is currently vec 3 0 0.
Oh, okay, right, yeah.
So now we can compute that in some way.
Mix that into
we can also experiment a little bit, see what that happens here. Now it gets, well. Turns out 75 was pretty good.
It's pretty spot on, that value, yeah.
We experimented with that very very scientific as usual on this stream. We do things. Yeah, this looks the best. Keep it.
Yeah, it's far too dark there.
So, and if I change this to 1, what happens then?
Okay.
That looks weird. That's okay. So the thing is, what's cool here is you have this distance here. This is the distance from the ray to the sea floor.
The sea floor, yeah.
And we can actually use this distance here to sort of kind of create this kind of, because the further this distance it is, the more towards black we want to go.
Yes.
So I'm just going to put here like something like this, like 3 0.
Okay, so you're going to mix. So you're going to mix it between black and
white.
Yeah.
There's certain functions that comes back over and over again, right?
Yeah.
So the mix function, the power function. So what we want to sort of do is, like, when we're close to when we're not so far from the underwater seaworld, we want it to be close to 0, and so on. And we kind of did that with our fog before.
We did, yes.
So where do we have that? Defog, fog depth, fog factor.
Yes, we took an exponential, yeah.
Yeah, that's how we roll.
Always a good one.
Yeah. So let's copy paste this fog factor.
Okay, got it copied.
And copy paste it inside when we're computing the water. Up.
Yeah.
So above the mix function.
Above the mix function.
Seafloor.
Seafloor here, yeah. Oh, is that the wrong one?
We called it fog.
That's the wrong thing, isn't it? That's
the factor. No, yeah, this is the wrong thing. Okay.
No, I'll go and get it. I'll go and grab it again. I don't know what happened there. Why it didn't exponential. Fog factor. There it is.
Oh yeah, it wasn't so hard to remember.
No, it's funny, isn't it? Okay.
Then we can call this float C. It's not really depth, but it's a C.
Yeah, it is. Yeah.
It's kind of, and what was it? D minus DC. For depth.
Yeah.
So what happens now? The higher C depth becomes, the more this goes towards 0,
Yeah.
right?
Yes.
And when it's 0, it's 1. So it means that wait a second. So when it's yes. So
C factor in there, yeah.
so it's not right, but it's a start, a multiplication.
Okay, so you can see it getting darker. Yes, it's definitely. Oh, that looks.
That's
I like
not
that.
bad,
I like that.
right?
Yeah,
It's
so
not,
that's now the kind of. Yes, that's
now it
very
looks.
good.
It's not really what, but it looks kind of like. It looks appealing.
It does.
Right?
It does very. That water, it's definitely like a water line.
So once again,
Perhaps it
with
shouldn't be
pure.
white. Maybe that's the thing.
Yeah. It should be. What was the sand color? Do we have the sand color?
We have a what was it called? Surface color was it called?
No. Undo. I think it was called sand color.
Could be.
I'm typing now.
Yes.
But it's to multiplication sign, please.
It's too intense, do you?
I think it should be colored a little bit more by the water.
Right, okay.
It doesn't look really right. How should it be colored?
I know it looks pretty good to me, but you're probably right.
That doesn't look right.
No.
I'm going to experiment a bit here.
Okay, yeah. Go ahead.
Crap. Undo. Undo doesn't work for me either. So
There you go. Oh, so I see where you're coming from. Yes, you're right. It needs to be. Yeah. That's amazing how you can get that effect.
yeah, what we're just doing is we are like.
Yeah, that's a good idea. Change it from black. Yeah. You can get really subtle here now, can't you? Oh, nice watercolor.
Yeah, you can see how much thought and careful planning went into this.
No, this is what I love about shaders, is that the way you can you can lose hours doing it, but you can just tweak and be satisfied. Then come back the next day and still carry on tweaking, making it different.
I kind of like when it went to revert to black, though.
Yeah.
I think I did prefer. I want to try that thing, right? To see.
I think it's right. That feels right, doesn't it? That it did that.
I'm gonna see how it looks on the screen now.
I'll hide the. I'll save it and then I'll just hide the editor as well. I don't know. It's a difficult one, whether that's the right colour or not.
No, but okay. So I'm not sure about the color, but what is right is that we want this kind of
we
effect.
want the shelving effect, don't we? So we can see there's water that's getting deeper and deeper, and the land is shelving away.
So is it the correct color? Hard to say, but I think we can agree we like this kind of effect. What
Definitely.
we're seeing.
Should we add some motion?
So what I also want to do is we should introduce a level here. Yeah, start it.
That's really interesting because you start to get some depth to the water now.
Yeah, you see here here the water is more shallow, so you can see there are more areas there. You can sort of see the underlying part of the sea, and that also breaks. Before the water was kind of this too flat, it looked very weird. Now this color we have might not be perfect, but I think we can agree. At least to me, it looks much more appealing, and we haven't even added shading, right?
Yeah, that's right.
So when we add that, it will improve even more. So we have just played with some basic tools here, but I think this improved it a lot.
I think it's definitely improved it. Yes. Let's just fly back to where we got some more sea.
And I think we have another way to sort of make it even better. So what I like is we can kind of see the shape of what's under.
Yeah.
There, we can sort of sense it. I think something we should do is we should add that the tree layer doesn't go entirely
all the way to the water,
but we instead add a kind of a sand layer.
I think that's right, because the trees wouldn't go all the way to the edge of the water.
No, so we want kind of an area where it's like the tree level doesn't get in here. But that should be simple enough to add. So we keep it here.
Okay.
But I also think the water, because of all this, it kind of breaks up the symmetry, so it looks better now.
It does look better, yes.
The waves, we know they are maybe too symmetric, but still, I think it improved by doing this thing here.
Yes. Oh, definitely. And there's subtle changes, but it's the subtle changes that make the difference, I think. I certainly like the water edge. So you got some water line around there now. It's very good.
Was it sea height? Oh, this is hard. Plus.
Yeah. Sorry. Should be on the ball. I think that's done it, isn't it? That seems to have done
it. Is it correct? You can remove the.
Now we're getting some shoreline.
Yeah, we have some shorelines here, right?
Yep. Yeah, definitely. And we got a bit of fog as well, which is interesting. That's nice.
We haven't added fog over water, by the way.
No,
that's also something we need to do, and that will also improve the fidelity.
It will, yeah.
Because what we can do is we can make sure that the fog clings to the edge, kind of here. It clings here, but not so much over the middle of the water, because that's kind of cool.
Yeah,
should be cool. All this we can cheat out, but we have kind of a layer here. Are we happy with this?
Yes, very much. That's really nice.
And you saw how hard it was for you.
It was really hard. It was like mega hard. It took you hours to do that.
Yeah. So I also think that this is something to take away, that when you see these kind of things, it can just be these simple comparisons and sort of, because the only thing we did is like, well, the tree height now has to be above sea height plus a little bit and below 0.3 and the flatness factor.
Yeah.
And that's it, kind of. Wow, that was amazingly hard.
And the flatness factor, remember, is there because we don't want trees to grow on vertical surfaces. So.
Yeah. And
or steep surfaces, that is.
So that's certainly doable. I actually think this is starting to look like something, right?
It really is, yes. It's like a work of art. And it's all through maths. People at work still keep asking me how many polygons are in this. I said, there aren't any polygons in it.
No polygons here. That's hard. I can't do hard stuff, so I keep to the simple stuff. My boss, actually, he's been doing kind of landscape rendering, and he talked a lot about this. We don't do any of that anymore, neither of us. And I used to work with a map engine before, like
right.
3D maps and 2D maps and these kind of things. Nothing like that anymore. And he talked about how to do loading on details to reduce the level of details and blah 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 blah, and how complicated everything was. And like, sounds too hard. I don't want to do that. I want to do simple stuff, like have some kind of random noise and add a little bit of noise and cheat it out, make it look good. Now, how do we get shades into this thing? Because we want to shade.
Yeah. Okay. I forgot about a mountain strata. You can't see the strata so much here, but as you get into the taller mountains later on in the as it plays through, you really set that banding really nicely.
So if we take the shade here, I think we shouldn't now reflection. The reflection isn't shaded because reflection is the reflected sky, and that it might be shaded, but it's not the. But what might be shaded? Okay. Yeah, you see, this is what happened when I press control.
Yeah,
so if you move this up above the seafloor.
Don't know what's happening sometimes. We go.
So I'm thinking if we can add it here, so a multiplication sign. Does it make any difference?
I didn't see any difference.
Yeah, but also it's kind of flat here, so we need to get. So what we can do here is because when it's flat, it's not really shaded. Where is the sea surf? Sea height?
Sea height's here.
Yeah. It's not really shaded, right? So
doesn't seem to be.
Control C again. Get it back.
Oh, you want to give that back?
Yeah.
There you go.
So there you go. Let's see how it looks. Let's see.
We're getting really subtle here, aren't we? So I mean, this is why there's a bit more kind of silence on the stream, because it really is quite subtle what we're trying to do here.
Yeah, a lot of experimentation.
Yeah.
Okay. You see, it looks like we're not in shade. It's white. So if it's strange. Or is it in shade over there?
There's some shade there.
Yeah, okay, that's good. Because then we can see how it looks when we... Because that makes sense. This is kind of in that area.
So you can see some shading, but it's quite subtle, and it's shaded out the shoreline there, isn't it? You can see it definitely a shadow
Yeah, because
there.
the shoreline is in shadow, but the reflection might not be it.
Yeah.
Because so my thinking about this is that this part here is driven by the sun, like
shining through there. Yeah.
Because reflection, when you reflect it, it's not... When you reflect inside, even if it's a shadow, it might still reflect and hit the sky.
Yeah.
So what we can do it later, is that we kind of what we can do later is that we can also make sure that we can check if the refracted ray hits the mountain, but that's more complex.
Yeah.
Well, let's leave it for now. It's okay, I think.
Mm.
Or do you agree?
Yes, I do. Let's fly along and see what.
I actually think this looks okay.
Yes, it does. Yes, definitely.
Right?
You can see. Yeah, you can see. Yeah, if you just go back there a second, that looks right, doesn't it? Because you've got this mountain here that's shading all that part there, and then this is in sunlight, so you can see further into the water because it's in sunlight. You've actually got a nice little highlight that's appeared quite randomly just there to emphasise it.
Yes. So I mean, we can certainly make this better, but I still think it's not... I mean, I still think we can be quite proud of this.
I think so. I think I'm really pleased with the sky. And if you look on this as well, this small preview there, that looks awesome.
What? That's weird.
Yeah, just wanted a little bit more water, don't we?
Here the mountain range is a little bit higher.
It's higher here, yeah.
But that's okay, right? Because we can have it's okay. But we can also make it's maybe it works out
I
well.
just find this fascinating. I sit here sometimes for quite a long time just watching this unfold. I just love the fog that's in there as you can fly over it.
Yeah. The fog we should add. How do we?
Then we get some nice lakes here. Look.
Yeah, there's a lake area, right?
Yeah,
I see that.
into lake area, and then we go a bit higher. Nice little lake down there. And we go into It's into the Highlands again now.
Yeah, I agree. I also when I did this my magnum opus thing, this is getting close to that actually.
Yeah.
I was just, as you say, I was just watching it unfold for hours.
Yeah.
You know,
You can. It's fascinating.
see what's happening.
Yeah.
And being fascinated by it,
And
like,
surprised about, look at that little bit down there, look at that over there, you know.
Yeah, and it's also it all formed by kind of random noise.
Yeah, absolutely, yeah. So one thing that you did mention last week was talking about anti-aliasing. Are we getting any kind of problems with aliasing effects? Because there are some kind of odd effects.
We get a little bit of that in the water.
Yeah.
I see. And that is fixable, but I think we probably going to run out of time to do
we'll
that.
do now. We're heading towards time when I want to close anyway.
But the way we do it now, that's going to increase the amount of work the GPU has to do. But okay. But the way we do it is you can actually change it to 1912, 1200 perhaps. That can make a difference.
Right. Okay.
So if you take the resolution here.
So what do you reckon?
1200.
720. 760 rather.
1200. No, 1920 times 1200. You don't want to reduce it, you want to increase it. Yeah, not much difference, but it can make a little bit difference. So what you do then is that you call get color, but you shift for each pixel. You render each pixel 4 times,
right.
But with slightly shifted offset, and then you add them together and divide by 4. That's the strategy.
Okay.
That's very complicated, but it actually does help. So what did we do today? We implemented some clouds by random noise. We integrated the clouds into our water shader, which turned out quite good, I think.
It did, but it's turned out completely awesome in this one.
Yeah, and then we integrated the clouds into this layer, and it turned out surprisingly well, I think.
Yeah, very much so.
And we also added water, which I think looks better now.
It does look an awful lot better. Look at that. That's really nice there.
It has to do with that it doesn't look as flat as before, because
it's more
like a flat mirror. Now it's more like it changes, the tone of it changes across of it, so it has a much more natural color to it. Yeah. I believe.
Yes.
And also the beach kind of makes it.
It does. That looks really good.
More believable.
Yeah. We even get some of this nice highlighting that's the sunbeam kind of highlighting on that beach area as well. That looks really good.
Yeah. So.
Yeah.
The waves are static. No, I don't think they are, but they might look static. They're not moving that fast though. Because if you look at the wave function, the wave height function.
Yeah, the gravity one here.
I might be wrong though.
Certainly got sine wave involved with time involved in it.
Yeah, with time here. So it uses the time factor, but it might be too little of the time factor. That's it. But now when we pause it, when it doesn't move, we don't see it moving. But when we play it, it's not obvious that it moves. Still, I think this could probably be a good wrap up.
Yeah, I think it's a good place to stop. we certainly achieved an awful lot. And adding to this shader is awesome. So yeah, so we can wrap up at that point. So what I'll do is I'll just push that up to GitHub as well.
Yeah. I think it turned out better than I thought it would.
Good. I'm glad of that, because I know that it was it's quite challenging to do this, isn't it? On stream like this.
And also before the stream, I wasn't really hitting it when I was trying for myself. I was like, yeah, this is acceptable, but I didn't think it looked that good. But I think we actually succeeded better on the stream. So that's good when that happens.
Well, that's always a bonus, because oftentimes you don't manage to do that. I often find that I get so far and then I have to go away and do some off-stream stuff. So if we have actually achieved more than you hoped for on stream, that's excellent.
But this is also what I want to get across a little bit. We talked about that before, but you see these shaders and they look amazing, and very good people doing it. But I'm pretty sure they've been sitting like we have been sitting and tweaking the values. 1.2, 1.1, 1.2 looks better. Keep it, and continuously, this looks pretty good, I think.
There you go. Is that not awesome?
I think so.
I'm going to screenshot it. Oops.
So
I'm going to do that.
So obviously very clever guys, very smart guys, and we haven't been completely random, but we have been tinkering a lot, and the end result is it's for a good cause. Get something that looks pretty cool. Yeah, I think it looks pretty good, actually.
I've had my cursor in that shot and I can have a look.
Yeah. We have to leave something in the shot so people don't think it's for real. You just took this picture out your window. Yeah, but I think many things we succeeded with here. I think the ice, it looks very nice. I like the forest.
Yes, I got my
has a nice look.
in there.
The highlighting of the different parts. The water has come out pretty good. And the clouds.
We'll post that up to up here.
So I think we can be pretty satisfied, actually. I've been watching a stream which is called what was it called again? Hydraulic press stream.
Oh right, yeah.
They're putting things in a hydraulic press and see what happens with it, and they get very sad when it doesn't explode. And they say pretty good. That's the catchphrase, and I would say pretty good.
Okay, so that's all up on GitHub, so people can download those Kodelife projects. I will have a go at putting this update into Shader Toy, but I don't know if we'll succeed. We'll give it a go.
And since we haven't used any assets, we just use random noise and nothing else. This is almost takes no space on disk.
That's right, yeah. Okay.
Any questions from Dragon's Eye before we leaving? He's our faithful shader viewer.
So Dragon Eye, we'd like to see some of your shaders. So you're going to have you tried any shaders yet? And if you do, we'd love to see what you could come up to. And that goes for everyone who watches either live or on the YouTube video, which will go up tomorrow. If you want to kind of do some shaders and tell me about it, then just join my Discord and post a link to your shader, and we'll have it on stream.
And put it on Shader Toy.
Yeah, if it's on Shader Toy, we can help you put it on Shader Toy. We can help you convert it so it can be displayed in a web page, and we can kind of highlight your work. So come on, Dragon Eye, the challenge is to come up with a shader. It doesn't have to be the most fancy shader in the world. Just do something, and we'll highlight it on the stream. So thank you for
it doesn't have to be 3D.
No. We started off with 2D with our kaleidoscopes and things, so you can do something similar. A dot on the screen, that probably won't count as. In fact, that might be
that's how everybody starts, The
circle.
That's how I started with graphics in the olden days. I got the single pixel on the screen, and I thought, okay, I can work with this. And then I had 2 pixels, felt like a king. So yeah.
Okay then, so thank you very much, Mårten. That's another excellent stream. So look forward to the next one. So YouTube, the video of this will be on YouTube within 24 hours of the stream. So if you want to go and subscribe to my YouTube channel, it's up there. I've got 84 subscribers so far on YouTube, so just 16 short of that magic 100. So if you haven't subscribed, then it's completely free to do so. So go ahead.
Check if I'm a subscriber.
Yes, it'd be quite good
I'm
if you
not,
were.
because then it's an easy fix.
Yep, it'd be great if you could. That'd be 85 then. That'd be wonderful. Yeah. So same on Twitter. Here's my Twitter account. So go and follow me on Twitter as well. We've breached the 100 follower on Twitter, which I'm very grateful for the people who've followed me on there. Okay, let's go and find someone to raid, shall we? If there's anyone around.
I wasn't subscribing. Now I'm subscribing.
Oh, thank you very much, Mårten. That's brilliant.
Click the bell.
So let's see if we can find someone.
Jitter Ted, I sometimes watch him.
Sorry?
Jitter Ted.
Oh, Jitter Ted. Oh yeah, we can go and raid Jitter Ted.
He's just Java, of course, but you know, can never be as cool as shaders.
Thank you for the subscription. Oh, that's very kind of you. Okay then, so let's go and raid Jitter Ted. So if you want to stay with him, just stay on the channel and we'll transfer you to there. And we'll see you on Wednesday afternoon. I'll be doing some Z80 emulation, and we're going to be looking at hex files. So I'll see you then. So take care, everyone, and have a good night.